Thank you. Hopefully you can all see that. So I'm going to talk about system change, not climate change. That's the title of my talk. And as always, I'm guilty of too many slides. So let's see if I can get through this in the next 20 minutes. We'll see how that goes. That's the challenge in and of itself. Next slide. As James said, my name's Neil. I'm a lecturer in infrastructure systems in the Department of Civil Engineering. My research is largely into understanding infrastructure as a system. I'll explain a little bit more about what that means. But yeah, the topic that I chose today is this system change, not climate change, which is a phrase that you see a lot in these kinds of, let me go back, a phrase that you see quite a lot, on protests around climate change that people sort of say when they're discussing climate change and climate impact. And the system in question generally people are talking about is the economic system, but I'm not an economist, I'm an engineer, so I don't want to discuss that specifically. What I want to do is to maybe take a philosophical angle and reflect on what that phrase means to engineers, what system change, not climate change, might mean to engineers. And we see that, I think, if you understand the system, you can change the system, or to put it the other way around, we can't change the system if we don't understand the system, if we don't know what the system is that we're talking about, and if we don't understand which system it is that we're talking about. And engineers are in perhaps a unique position. They're not alone in this position, so it's not unique to engineers, but they're in a good position in the sense that they have the opportunity to change the system and the skills to change the system. And the system of interest to me is the infrastructure system. So as I say, my research is in infrastructure, specifically understanding how each piece of the infrastructure works together as an entire network. What is infrastructure? It's the generic term for all of the basic physical structures and assets that underpin life in general, civilization. So every engineer is involved to some degree in creating that infrastructure for life. And as this Treasury document goes on to say, we think about those as existing as separate sectors and assets, but actually they all work together, and they work together as a single system to create the things we need. And there are economic infrastructures like transport, energy, water, communications, ICT, waste, and then there are social infrastructures like health, food, education, justice, government, finance. All of those things touch on engineering, and engineers touch on all of those. And this is a model I use to try and understand what infrastructure as a system means. So infrastructure facilitates our fundamental needs, things like a cup of coffee. And your ability to make a cup of coffee is dependent on the vehicle that delivered it to your door or delivered it to the supermarket so that you could buy it. It's dependent on water coming out of the tap to go into the kettle. It's dependent on the grid bringing energy into your home so that the kettle works. So making that cup of coffee is dependent on all of those infrastructure systems coming together in your house and working together. But equally, the vehicles that carried the coffee is dependent on the road infrastructure, and the coffee had to come into the country, so that's dependent on ports and shipping infrastructure. So who's designing those ships and what are the impacts that those have? The water had to be treated and sanitized, so there's a whole system of infrastructure that exists that's dependent upon. That has to take power from somewhere, so the treatment of the water is dependent on the energy grid, and the energy grid is dependent on where that electricity is being generated and how it's being generated. And then there are all kinds of other systems the further out you go. There's the agricultural system that grew the coffee in the first place and all of the inputs and outputs that has. There's the commerce system and all the ICT and the financial systems and servers that back up the ability to actually buy that coffee. And all of those things consume resources, all of those things have impacts. So it's important to try and understand how infrastructure works as a system to facilitate our needs, and how infrastructure works as a system to have impacts on the climate. But our tendency is to focus on one little bit. All of that is too complex. So we split it all up into little pieces and we focus on one bit. I'm going to focus on the vehicle. I'm probably not even going to focus on the vehicle as a whole. I'm going to focus on one part of the vehicle, the materials it's made from, or the batteries or something like that. And I'm aware of climate and climate impacts, so I'm going to re-engineer that component to be more sustainable. But really under the assumption that once that's slotted back into the whole system, it all scales and works together to deliver an entirely sustainable system. But swapping from an internal combustion engine to a battery doesn't help if the electricity that charges that battery is still being drawn from non-renewable resources. So this whole system angle is really important, but we tend to focus on one little bit. Also, we tend to focus on quite a temporal segment. So it's not just about the resources that are used or the waste we generate in making these systems of infrastructure or the things that we engineer. It's not just about the resources that we use and the waste we generate in operating these systems, which we might tend to think of as the life cycle. We think about what went into making them, what goes into operating them, what happens at the end of the life. But there's one other thing that we don't tend to think about that much, which is that the things we create, the things we engineer, infrastructure, all other products that engineers are involved with, they shape the behaviors of society. By building a road that links two places, you determine that people can get between those two places. So all of these things that engineers do have an influence on the way in which people act. And we can, by building these things, we determine whether people are able to act in a sustainable or unsustainable way. We influence them to act in a sustainable or unsustainable way. And we're not always thinking about that level of the system. So in the kind of the systems approach, people talk about this iceberg model, and they say that down at the bottom there are systemic structures, and those systemic structures generate patterns of behavior, and those patterns of behavior result in particular events. And from our perspective, perhaps today what we're talking about, the systemic structures are infrastructures, and they generate patterns of behavior in the people who use those infrastructures to go about their daily lives. And those patterns of behavior determine climate impacts and other impacts on sustainability. So it's not just about the manufacturing, construction of those products. They're super important, but it's about the impacts they have on society in general in terms of how they shape their behaviors. So this infrastructure carbon review, it's quite old now, it's from about 8 years ago, but they identified that 16% of the UK's total carbon emissions come directly from infrastructure. 37% come from those secondary factors, the fact that the infrastructure influences people to act in particular ways. So 37% of the UK's carbon emissions can be indirectly linked to infrastructure and what it enables people to do. And because a lot of other sectors are decarbonising, by 2050, it's projected that 90% of carbon emissions in the UK will be directly and indirectly linked to infrastructure and its behaviours. So that's why big engineering organisations like the Royal Academy and the ICE are interested in this idea of decarbonisation. And it's why when they're talking about decarbonisation and net zero, they bring up this idea of the need for an integrated systems approach. And that means going beyond just looking at one piece of the puzzle, one piece of the infrastructure system. It means going beyond one slice in time. But equally, and something these don't quite get to, is it means going beyond one single metric. So these all focus on our old friend carbon, which is of course really, really important. Minimizing the amount of carbon emissions, the carbon impacts and those kinds of things is really important to climate change. But it is just one piece of the sustainability puzzle. So in the UK, the construction and operation of the built environment accounts for 60% of all materials consumed, 1/3 of all waste generated. Those things are really important. But anyone who was in the previous session will have seen Brittany talk about the Sustainable Development Goals that the UN put together. And climate and carbon, they're only one part of this complex puzzle that makes up sustainability. And the fact is we have the technology to decarbonize. We could remove carbon, we could reach net zero. Decarbonising is easy if you don't care about poverty, hunger, health, justice, and the unequal distribution of the impacts of making those decarbonisation pathways. So actually stepping back and trying to think about how we achieve sustainability in terms of all of these goals, so decarbonising in a way that is equitable, is what makes it a real challenge. So beneath those goals are specific metrics about what the globe is trying to achieve in terms of hunger and sanitation and climate and poverty and those sorts of things. And all of those metrics interact with one another. All of those targets are potentially in conflict with one another. So this matrix shows the relationship between those goals, and the red squares show where those targets are in competition with each other. So where achieving one makes it hard to achieve the other one. So we have to account for all of these things as well. So naturally, it is very, very complex. And as I said before, our tendency is to draw a boundary around things. And we draw a boundary around a small part of the technical system, and we look at it in isolation. We draw a boundary around a small part of the process in time, and look at the climate impacts associated with that. And you're still making those boundary decisions, even if you're doing a life cycle analysis. We draw a boundary around a particular geography, and we become less concerned about things that are happening further away from that geographical boundary. And we draw boundaries around specific targets like net zero carbon, and we ignore important targets that sit outside of that boundary. So we make these changes to our little tiny bit of the system based upon this little tiny view, and we pat ourselves on the back, and we do more things to be more efficient at the things that we probably shouldn't be doing anyway. And we celebrate this and we think, does this all actually scale? Does this all make the world better? And you know, I would argue it isn't. We actually need to go further than that. So does the infrastructure system need to change? System change, not climate change. Is it the infrastructure system that needs to change? Yes, it is, because that impacts on people's lives and how they live their lives. But we have to go one level deeper than that. And so I just want to do an experiment with you. I'm going to run a little bit over 20 past, if that's okay, James. I'm aware of the time, but given that we started a little bit late.
Yeah, we started 5 minutes late, so you've still got easily 8 minutes.
Okay, perfect. 8 minutes is fine. So I'm going to do a little experiment, and those of you who are watching, just indulge me and follow along if you could. Here's the experiment. What we're going to do is I'm going to show you this grid of images of Bristol, and I'm going to give you some instructions. Some of you who are watching this may have seen me do this before, so sorry about that. I'm going to give you some instructions to follow, and I want you to follow those instructions. Sometimes the instructions are quite prescriptive, and you have to do exactly what I say. Sometimes you have complete free will, and you get to choose what you're going to do. So if you don't have a touch screen, you could maybe put your finger on one of these images in the grid, or just locate yourself on the grid. Just pick one as your starting point, and you have complete freedom of choice. There's 9 images there. You get to pick whichever one you want to start on. It's totally up to you. And you know, maybe there's a preference, but with 30 odd people on this meeting, everyone will probably pick a different one, or there'll be different ones selected. So now what I want you to do is move one space to the left or right. It's your choice, but you do have to move. So if you picked one on either side, then that choice has sort of been made for you. But if you picked one in the middle, you get to choose whether you move left or right. So it's your choice where you move one space left or right, but you do have to move. Now move one space up or down. Again, it's your choice, but you do have to move. There's more instructions and they get a little bit more complicated. So move one space to the right, if possible. Otherwise, move one space to the left. Now move one space down if possible. Otherwise, move one space up. More complicated still. If you're now in the left column, move one space to the right. If you're in the middle column, move one space to the left. If you're in the right column, stay where you are. If you're now in the top row, move one space down. If you're in the middle row, move one space up. If you're in the bottom row, stay where you are. There are more instructions, but I'm going to go more quickly now. So again, move one space left or right. It's your choice, but you have to move. Move one space up or down. It's your choice, but you have to move. Move one space to the left, if possible. Otherwise, move one space to the right. Move one space down, if possible. Otherwise, move one space up. Okay, so you should all now be in a particular square. And by the power of magic, I'm going to predict that it was the Clifton Suspension Bridge, this one. Now, if you've all done that right, it should be the Clifton Suspension Bridge, because I know it works. I know that those instructions will lead you wherever you start to the Clifton Suspension Bridge. And that should be the case for everyone. So if you didn't end up there, I'm afraid you didn't follow the instructions correctly. But the point I'm trying to make is this, is that if literally thousands of people, and these experiments like this have been done on people thousands of times, from diverse backgrounds, they all generate the same endpoint, regardless of their starting point, then the causes of behavior, the things that are shaping their behavior, is not their attempts to do things differently. It's the structure of the game itself. It's the rules of the game are shaping you and influencing you to do something differently, to lead you towards a particular outcome. So even if you're trying to address climate change or any of the sustainable development goals or all of the sustainable development goals within a system of rules that is trying to force you not to do that or to do things the other way, the old way, then you're going to come up against problems. So in engineering, what is the structure of the game? Well, it's best practice, it's legal system, it's the business models that we operate under, it's the contracts that we draw up, it's the policies, it's the procedures, it's the sets of rules that individual disciplines and organizations may have. And trying to make changes within those rules, as I say, can still lead you ultimately to the same outcomes despite your best intentions to arrive at different ones. So to change the system, to change the outcomes, you need to change the system, and the system is the rules of the game. So if we think about that first iceberg model, there's another one that sits beneath it, the one that creates the infrastructure. That's the policies, the best practice, the rules, the regulations, the things in the engineering design world lead to engineered products, which then go out into the world that shape the behaviors that people adopt, which impact on the climate. So is the system that we need to change the structure of engineering? Well, yes, it is. We need to change the structure of the engineering rules, the contracts that we draw up, the way of working. We need to change those kinds of things. We can't persist with this piecemeal improvement of the parts. We can't persist in a structure which prevents us from collaborating and working across those silos and gaps. But I'm going to argue there's one more layer. Below even those rules, there's our mental models, our paradigms, our worldviews. There's our system of thought. And the predominant system of thought is the one that forces us to break things into parts and neglect the whole. So deep down within us, and the way in which we're educated, the way in which we're informed and everything is driven towards this idea, this process, this method of taking what some people call a reductionist approach. Now, that reductionist approach, it was defined by Descartes. It's about taking a complex problem and naturally you want to break it up into smaller parts to try and understand it. So you take one little bit and you take it away into a laboratory and you understand that little bit in isolation. And you imagine that when you put it back into the real world, back into the context of the complex whole, it will work. But that doesn't necessarily always work. So there's this even older philosophy, an even older approach to problems and worldview and paradigm, which is the systems approach of Aristotle. The whole is more than the sum of its parts. You can't just assume that when you put all the parts back together, you'll get an optimal whole. But it's also important to realize that these are complementary approaches. Both have weaknesses, both have strengths. Some are more compatible in some places, some are more useful in others. Reductionism has got us to where we are today. It's a very powerful thought process. There are lots of problems we couldn't have solved if we didn't take a reductionist approach. But the sorts of problems of sustainability and climate are complex problems, and they can't be solved by taking a reductionist approach. This reductionist worldview is one that makes us see the natural world as different pieces, and different pieces to be exploited by different people, different artificial boundaries that we put in place. But the real world doesn't care about these boundaries. It doesn't care whether you're a mechanical engineer or a civil engineer. It doesn't care whether you're a politician or an economist. These are all artificial boundaries that we've put in place to make our own lives easier. And if we think in that way, if we think in a fragmented way, then we act in a fragmented way. Then we can't deal with this idea that actually everything is connected to everything else. We need to change our mindset to a way that enables us to think about everything as being connected. So all these sorts of problems associated with sustainability, about food security, energy security, equality, poverty, globalization, conflict, economic systems, well-being, all of those sorts of things, if we see those as separate problems, then we won't be able to solve any of those problems because they're all connected. If we focus on any one of those parts, then we end up with a suboptimal whole. So does the system of thought need to change? System change, not climate change. I'm kind of arguing here that the thing that we need to change, the system, fundamentally, is our system of thought. And I'm just going to leave you with a slide to let you read this quote from Zen and the Art of Motorcycle Maintenance, which I think kind of sums up the thesis in this little talk. And that's me concluded.
Great talk, thanks very much. And for people just joining, we'll take questions at the end, but feel free to ask them in the Q&A throughout.
Yeah, fantastic. I'm going to have to go back and pause it on that slide so I can read the full quote. Steve, over to you.
Great. So hopefully my screen is coming up. Can you see it okay?
Yep, got it.
Fantastic. So firstly, thank you. Thanks for the invitation to come and talk today. I've been looking forward to this, and you know, it's clear from what Neil was said that there's no simple answers to some of the questions that we're exploring today. But what I'm going to do is just to share a few personal reflections, share a few stories, and also talk a little bit about what we're doing at my company WSP, just because I think it helps to ground some of the things I want to say in what's happening in practice within large engineering organizations. You know, and Neil, it's a real pleasure to follow a fascinating presentation, and I really like your focus on systems. I have the privilege of sitting on the Engineering Policy Committee at the Royal Academy of Engineering, and the kind of issues that we deal with there, it kind of always follows a pattern that an issue gets brought to that table, and we sit there debating it for a while before we come to the inevitable conclusion that it's a systems-based problem. And actually that whole mindset was one that inspired me to supervise a series of engineering doctorates at the Systems Centre at Bristol University, and I learned a huge amount from that. And I thought, sort of building upon what you said, it might be fun to start with a little bit of a story. And this is an absolutely true story. And now, when you travel on trains, and when we're able to again, when you travel on trains, if the train's delayed, you get an announcement, and they tell you why the train is delayed. Now I'm of a generation when it wasn't always like that. And if you go back about sort of 15 or 20 years, when you traveled on trains, if they were delayed, you used to hear nothing. And then suddenly there was this change, and you started getting announcements, and these sort of bedded in after a while. And I remember getting a train back from London and hearing the announcement, we are sorry that the train has been delayed. This train has been delayed because the train in front is delayed. And you kind of sit there thinking, thank you for the announcement, but that hasn't told me a great deal. And then about a week later, I was sitting on a train back from London, which again was delayed. And again, there was an announcement. And the announcer said, I'm very sorry that this train has been delayed, but the train's been delayed because of 25 years chronic underinvestment in the rail infrastructure. Which again was probably true, but actually wasn't particularly helpful in me trying to judge whether I was going to get home in time or not. But I think for me, what was really interesting about it was the problem they were having keeping trains on time were clearly a systems issue, but you look at it through one lens or another lens alone, and you really don't get any interesting or useful information. It's only when you start to combine this information and you start to see the whole system that maybe you start to have a chance to tackle things. So I'm going to talk today, as I said, a little bit around sustainability. What should engineers do next? And I thought I'd start with another story as well. So my wife works in television, and when we first got together, I remember having a dinner party in London, and everyone there was from TV, and I was the only engineer who was there. And there was a lot of chat around, you know, who's been commissioned to make what, and a little bit of gossip about various kind of vaguely famous people and what they were up to. And then after a bit, attention turned to engineering, and everyone was interested in what I did, because I guess a lot of what they did was quite ephemeral. And what I do as a bridge structural civil engineer, it lasts. And we had a really interesting conversation around it. And then someone turned to me and said, okay, but those are the projects you work on, but what do you actually do? And I really struggled to answer that question. And I felt really disappointed in myself because I thought, I'm passionate about engineering. Surely I should have a better answer for that question. And I kind of took that nagging doubt with me. And I was sitting in a European meeting a few weeks later, surrounded by engineers from France and Germany and Italy and others. And it just kind of dawned on me that whereas we spell engineering in the UK with an E, all of the engineers from other countries were spelling it with an I. And in doing it, there was that greater proximity to the linguistic root. And of course, the linguistic root of the word engineer is ingenuity. And when you look at, a definition I like of ingenuity, the ability to solve difficult problems, often in original and creative ways. I'd kind of wish that had been on the tip of my tongue when they had asked me, what do I actually do? Because I think engineering, the ability of engineering, the application of ingenuity, those solutions of difficult problems, often in original and creative ways, really captures the essence of what excites me about engineering. And when we think in the context of the challenges that we face, and those challenges around the Sustainable Development Goals, and those challenges around carbon and net zero that I'll touch on, isn't this what they demand? Isn't this what they demand? And if this is what they demand, isn't it engineering that they demand? So I talked a little bit just while people were joining around my background. I guess another thing that I've learned is that, in order to understand people's perspectives, it's a lot easier to follow them if you know their viewpoint, and their viewpoint is based on what they've seen very often in the past. So in terms of my background, as I've already mentioned, I head the Civil Bridge and Ground Engineering group within WSP and lead our technical leadership function. So, I'm responsible for a business with 650 staff, a £50 million a year turnover. I chair CEN-TC 250, that's the committee responsible for the structural Eurocodes internationally. So we are currently in the middle of the largest standardization program in European standardization history to generate the second generation of the Eurocodes, probably something around 15 to 20,000 experts across Europe, all engaged in this collective collaborative effort with massive impact. And I'm visiting professor at the University of Bath, as I mentioned, the links with Bristol as well, the Royal Academy role, various other things. But I think also one of the things that's important to me is that I spend at least 50% of my time on projects. I've always been committed to staying close to the engineering and what we do, and my role on projects is sometimes around our strategy for delivering a major project, but very often it's actually getting into the real detail of some of the most technically complicated issues that we are trying to tackle, and actually it's a real privilege of mine that WSP has a business model that enables me both to lead a very large business and also spend time getting involved in very technically orientated, difficult issues. And actually I believe we're a better business for it, because that proximity to what are the driving issues on complex projects, I think gives us better insights in terms of how we construct what we do and where we focus our efforts. And look, I think Neil talked really coherently, really well around some of those tensions that we encounter. And I've been acutely aware in recent months around some of these tensions and some of the tensions around the Sustainable Development Goals. Because at WSP, we've made a really big commitment. We've made a commitment that in our UK business, we'll halve the carbon footprint of our designs and advice. So our carbon impact, we will halve it by 2030. Now, some of you may look at that and say that's not enough. It's a really significant challenge for us to do that. And we've also committed to getting to a net zero emissions position in terms of operations by 2025. Actually, that's relatively simpler, although we're trying to do it properly and not by offsetting, and that does bring some interesting challenges for us, particularly around travel. But that first one is the one that I wanted to focus on, and I want to share it with you because I think that it's important to recognize that there's a real appetite and commitment around this change. And part of the focus that we have here is complementary to what's happening elsewhere within the sector. And working, I'm working with colleagues on this, including a great friend and colleague of mine, Rachel Skinner, who's currently president of the ICE, and her whole presidential year is focused around this Shaping Zero theme. And working together and having debates, it throws up, a host for me of really interesting issues that touch on some of those tensions. So if we think in terms of carbon, this very simple diagram talks to the fact that actually, if you want to reduce your carbon impacts, the easiest way to do it is to build nothing. But if you build nothing, how does that help fulfill the other objectives that we have, the other goals that we have? But if we just focus on building efficiently, that's only going to take us part of the way down the track. So we've got to do better than that. But I think also what's interesting for me is when you start broadening out the way you think about this. So if we move to this picture, which I've taken from the London Energy Transformation Initiative, where they look at the stages of, in fact, this case, built environment, and where does the carbon come from? And you have that big bit at the start, and you have a piece at the end, the operational piece through the life. And I think what's kind of interesting here from an engineering perspective, and probably when we all look at this, we're sort of drawn to think about that life cycle, and probably our eyes are all drawn to the big bar on the left-hand side. But actually, for me, when I think about the engineer's contribution and what we can do in this whole territory, and particularly with the focus that I have around civil infrastructure, bridges, ground engineering, certainly within the UK, a huge proportion of our infrastructure exists today. A huge proportion of our building stock exists today. So we're sort of drawn to coming to this sort of life cycle picture and thinking we're at the start of it. We're not. We're a long way through it. So actually, this block to the end is probably the piece which is of most importance. And for me, it's a question of, well, how do we extend the life of our existing infrastructure? What can we do that makes it possible that the bridges that were built that serve, so much of our transportation network, and many were built through the 1950s, 1960s, 1970s, they're getting to a point in their life when they're starting to get of an age where you've got to ask questions around how much longer will they last for, and what can we do as engineers to extend the life? Isn't that a fascinating area for us to be thinking around the contribution that we can make? And actually, those kind of questions for me don't get drawn out nearly as often as they might, because our attention is often drawn to the things that we can readily measure, which might be the embodied carbon, for example, within a structure, or the operational carbon within a heating system. Those are relatively straightforward. Quite how we account for life extension and the fact that we don't waste material is a different sort of question, and perhaps again touches or resonates somewhat with Neil's point around the need to think in terms of systems and not in terms of discrete assets. I was also sort of taken as Neil was talking around another conversation that we're having within WSP, because one of the other commitments that we've made is we have a global program called Future Ready, and it's really simple in its thinking. It's just that we get involved in thousands and thousands of projects, and we've challenged ourselves to think about the future trends that are going to happen around climate and society and technology and resources. And we've committed that at the start of every project we do, we will pause and we will ask ourselves, is this project, as we call it, future ready? Is there something we could do to adapt to this project, change this project in a way which would make it better in the context of those changes that we can foresee in the future? And it's leading me and others to think in terms of a family of what I call design fours. Design for adaptability, design for resilience, design for performance measurement within a system itself, design for special requirements. And we're kind of growing that family of design for concepts, which which I suspect James and Neil as academics might know, that there's probably some wonderful literature in this whole space that I'm unfamiliar with, and it may be the terms I'm using are well established, but for us, we're kind of learning in this space, and the design for concept is one that I've been working on and developing for a while, and kind of like, because it makes it real and tangible for engineers. But I think the other point around this, and again, it kind of plays back to what Neil was saying, is that our thinking is that, you know, we see our commitment in relation to net zero as a subset of our broader commitment around sustainability, and really challenging ourselves, because we're in a position of influence, to say, are our projects future ready? Are our projects going to be able to deal with what they're going to need to confront with, what they need, the communities they're serving in the future? Are they going to work in the future as well as work today? And look, in terms of the carbon piece, again, we're recognizing this is I've taken this from a colleague. I borrowed it. He presented it to me yesterday, and I thought I'd share it with you today. And he was mapping out in our property and buildings team. He's from a structural engineering background, and they do brilliant, you know, amazing projects. Shard is one of their projects in London, but kind of fascinating, wonderful projects. But they have they're looking at that halving our carbon impact ambition and saying, how do we do that? And looking at it in terms of, if that migration improvement of best practices will get us partway down the track, but actually you need real transformation in order to achieve what we really want to achieve. And then we start unpicking that and saying, well, part of that's about material efficiency and how we standardize and better standardize the way we do things. Part of this is around, you know, further in-house technical material that we can develop. Part of this is about our influence around the project brief. You know, we get these from clients, but what can we do to challenge those, to shape those? Part of that is around our own internal research and development. So we ring-fence a proportion of the R&D tax credits that we get, and we reinvest those in research and innovation activities. And at the moment, we are finalizing the 5 big areas that we want to invest in this year, all targeted towards net zero. How do we shape the thinking of our existing clients, migrating to new clients whose thinking aligns with ours? What about our supply chain? Because we rely to a significant extent in our designs on the products that are available within the market. How can we work with material suppliers, for example, to move towards, you know, net zero concrete, steel? You know, there's some really massive challenges that have got to be addressed, and so we need to be operating and are committed to operating in that space. You know, the broader way the industry operates, the standards that I take a leadership role in developing, but then also within government and regulation, and we have the opportunity sometimes to influence that as well. But you'll kind of get a sense that there are so many things to go after here, and actually to achieve what we want to achieve, we've got to make progress against all of these fronts. And I think for me, one of the things that I draw from that, one of the things that hopefully you'll see over these previous slides, is a sense that we are trying to frame the question. I mean, I know that people will look at large engineering organizations and question whether we're doing enough and whether what we're doing fast enough. Very legitimate questions. But in terms of framing the question, I learned a lesson when I did my PhD. And in the early days of doing my PhD, I went to all the research students used to go to the pub on a Friday evening. And I spent one Friday evening going around all the people that were about to finish their PhDs. And I said, so how does it work? And they all gave me a pretty similar message. And, you know, my PhD wasn't so different. They said, you spend 18 months getting nowhere. You have this glorious 6 months when you come up with all the answers. And then you have this slog for a year as you write up your thesis and communicate the answers. And what I realized about that in time was that what actually is going on in that first 18 months is not that you're doing nothing, it's that you're working out what the question is. That the question is the most important part of research, and it's the hardest thing. Actually getting towards the answers tends to be a really invigorating and fun time. Communicating them can be a slog afterwards. But hopefully what I've shared with you a little bit today is those efforts to try and understand the question, to understand where our points of impact are. And I think for me, as I start to look forward and I think about what have been some of the highlights of my career, you know, this bridge, which some of you might recognize, which is just on the outskirts of Exeter, the reason I'm showing it to you is really nothing to do with the bridge itself, but actually it's the first bridge in the UK that was designed, first structure in the UK that was designed to the complete suite of the first generation of Eurocode. So from an engineering point of view, it's actually a real landmark structure. I'm kind of fond of the bridge as well, but it was a real first. And for me, there's something exceptionally satisfying in being involved in firsts. That some people seem to be driven by an ambition to do the tallest or the longest or the widest or the deepest. I'm kind of passionate about firsts because you do a first and it's always a first. And I look at those challenges ahead of us and I think there are so many firsts that are available to the next generation of engineers to come along and do. And the other point I want to close towards is a point around impact. I talked about the Eurocodes and the work I do on the evolution of the Eurocodes. This is a book I wrote at the time we implemented the first generation of them. The Eurocodes that I'm involved in developing are used by over 500,000 engineers around the world. They impact on somewhere between 10, 11, 12% of GDP. They have massive impact. The decisions we make in the committee rooms, the stuff I'm trying to steer in terms of coverage of climate change, opening opportunities to use lower carbon impact cements, these kind of things, they can have profound impact. And I think that engineering can have, you know, I think, Neil, you talked to the fact we need to have, and actually we're lagging behind in some areas, but it's also, we've got the levers, you know, we do have the levers to change things. So I just wanted to close by saying, you know, I hope that people can feel excited and reassured that the commitment is there. I think it really is. The piece we need now is the ingenuity and the solution to these problems. And that, I think, is what we've got to confront over the coming years, which means that I think there's a really exciting place in engineering in addressing all of those goals and the net zero piece in particular. So James, thank you. I know I've run slightly over time, but I hope that that's been interesting. And it's, again, a pleasure to have the chance to share a few thoughts with you today.
Oh, thank you so much. It was amazing. I love it. I love that ingenuity piece. That's really, really helpful. Over to you, Gabriel, to host a Q&A. And if you haven't already, do pop questions in the Q&A panel.
Yeah, great talk. Thank you very much. So the first question from Peter is for Neil, I think. And he asks, what sustainability goal do you think is missing and should be added to the UN's list?
Great question. Thank you, Peter. Well, I think there's one argument that the UN has taken a relatively comprehensive and holistic view in putting together those goals, and that one of the key things that's missing is that appreciation for the conflict and interaction between them, and actually that you can't just focus on one, because you do quite often see people focus on one area or select several with, you know, and then just ignore some, just decide, you know, we're going to look at 9B and 6D and, you know, and then, you know, ignore the others, or they don't apply to us. And just because you don't have direct control over them doesn't mean they don't apply to you, and you don't, it's not important to monitor them. So there's one argument, I think, that is that one of the key things missing is the emphasis that they're interdependent, that they interact with one another. And I think the second point, if there was one that was missing, it kind of is there, but it relates to one of Steve's slides about the future ready, and one of those lenses was the technology lens, and I think that's relatively downplayed in the SDGs. I think it's in the infrastructure one. 9C, I think, is about technology, but given the way the world is moving in terms of digitization and access to online services and those kinds of things, you know, so it kind of is buried in there, but I think it should have a higher profile in terms of the equality of access to digital services, if that's the way that the world is going, and indeed the delivery of those services. So if I had to pick one, I'd probably one of those. I don't know whether other panelists have any other.
Neil, I think your point on the tensions between them, I think, is really interesting. And as you were talking, it reminds me part of the fun of trying to lead the evolution of the Eurocodes, which is a slightly daunting job, to be honest, because fundamentally my job is to try and get 34 countries to agree on over 5,000 pages of technical material. And you can imagine that they don't all start from, they all start off agreeing. And actually, I think the point about how you get to consensus is really interesting. It's been a real theme for me, and I've learned a lot over the last decade or so in trying to enable the countries to reach consensus positions on complex technical issues. And I think for me, what's so fundamental about consensus, and let's understand what consensus is. Consensus is where a group reaches a destination, comes to a conclusion that everybody can stand behind, even if it isn't everyone's number one preference. Consensus is a really powerful instrument, but getting there is a journey. You don't just arrive there. And one of the most important things on that path towards reaching consensus is taking the time to listen and understand other people's perspectives, because until you understand those different viewpoints, you won't get to consensus. Because in my experience, what actually happens is that people disagree not because they're coming up with one is right and one is wrong. That's not why people disagree. Fundamentally, my experience is that people disagree because they're answering different questions, but they don't realize that they're answering different questions. And that is, and so actually you have to take the time and have the generosity to deeply understand the perspective of the other person and the question they're answering. And when you do that, suddenly it's as if a light bulb comes on and you can see a path towards consensus. That's a whole nother talk. I can do a long talk on consensus building. It's been a fascinating journey for me.
Yeah, totally.
James, would you like to add anything to Sustainable Development Goals if you want to?
I mean, no. The only thing I'd say is I'm currently reading Donut Economics. I don't know if anyone else has come across Donut Economics. I'm really enjoying it. And I think it does talk a lot to what Neil is saying about needing to think about systemically about all the different pressures and kind of, having a more holistic view. So I'm 3/4 of the way through it. I've been reading it for about a year. This year, 2021 is going to be the year I finish it. And yeah, it's very good.
Great. So there's a question for Steve. So how will the company ensure net zero travel by 2025, and what's the new travel strategy? I'd like to add a little tack onto the end of that. Is you briefly mentioned about carbon offsetting, and I'd like to ask what your thoughts are around that.
So, I mean, in terms of travel, when we look at, we actually, so we started off and we set ourselves a sort of trajectory to get to that point in 25. We actually have initially made some really strong progress. Last year, really strong progress because we weren't traveling. But what it told us is actually that travel component is really significant. What do we actually do? Do you know what? We have an internal tax on all flights. We have strict rules about flying within country. We make essentially we make it unattractive to fly, just to try and put some weight behind the words that we have. We try hard to reduce travel. I think we've learned a lot. I mean, the pandemic has been devastating in so many ways, but I think that there is a legacy that we'll learn from it that will have some positive elements, and one of those is our ability to operate remotely. I would rather be in a room with you all right now. It would be more fun, it would be more engaging, but you know what, we've got so much better at these kind of interactions. I think we've just got better at it, and I think we can do it quite well, and it's quite effective. And so I think we're part of the legacy will be that, and the way in which we use digital tools. But no, we don't have all the answers on this. Being with people, being present matters. We're involved in projects where you have to be there. So we're kind of working through that. And your follow-on was remind me.
Carbon offsetting. You mentioned you said something along the lines of not doing. Well,
Look,
things properly.
this is a very personal view, but and I need to be probably a little careful how I express it. But there are other organisations in our sector who have sort of made declarations that they're there already, and the way they're there already is they've just written a big check to offset what they do, and I think that we just don't feel like that's right. I mean, I can't, you know, there would be others who would be much, you know, better able to articulate whether offsetting is a legitimate approach or not. But I think that we just feel as though what we should be doing is trying to use less carbon. And that's the reason why I've got that objective. And that's the reason that we're trying to do what we're trying to do. And so we're trying to kind of achieve the metric, but via a different, it's like the measures are always a proxy for an objective. You know, you define an objective and you have a measure for it. The problem with measures, as Neil talked about, is that they can sometimes generate perverse incentives. The reason we've got that measure is because we want to reduce our carbon impacts. So to then use a mechanism that doesn't actually reduce our carbon impacts just doesn't feel right to us. And I said there would be others who would be able to argue the merits or dismerits of that kind of approach with a far greater inherent understanding of it than I do. I guess for me, it's just quite a kind of, you know, it's just what feels right. And it just feels right to say we want to do this actually by reducing carbon.
So in that case, do you think the carbon credit scheme in itself is a future-ready approach?
Well, I think the if people haven't watched it, I'd really urge people to watch Rachel's presidential address. You can get to it on the IC website. And there's a really simple little kind of metaphor that Rachel uses in that, which is about a bath with water flowing in and the tap and the plug hole open, and it's about things being in balance. And I guess the challenge, you know, the future world is not one in which there is no carbon expended. It's just got to be in balance. And I think that I guess my instinct is that mechanisms that enable us to think around how you get things in balance, and we value in some manner carbon, for me sort of feels like it makes sense. But so long as it aligns, so long as things are structured in a way which aligns with the core purpose rather than creating perverse incentives, that's the piece that always worries me. But said there are people far more expert than me in that field, so I couldn't give you any more than that.
Yeah, thank you. An excellent answer. We've got, I think, on the time slot anyway, 60 seconds left. I don't know, are people busy after this? Is this something we want to continue, or is this a... So I think we've got a good discussion going, but obviously if other people have other commitments, then...
Can I say, sadly, I do have to jump across coincidentally into a meeting with our water, energy and industry colleagues to talk about their net zero strategies. So I do have that at 2 o'clock and they will be waiting for me. So I'm going to have to drop off, but it's been a real pleasure to do this today. And I hope people can take away something useful from those stories. But I really thank you for the invitation. It's been a pleasure being here.
Great, thank you so much, Steve. Yeah, thank you so much. I'm happy to stay on for a couple more minutes. I'm aware there's one more question unanswered.
I have to go, I'm afraid. I have another meeting.
No worries.
So thank you, everyone. No, thanks, James, Steve, Gabriel. Thanks for
Neil. Thank you so much.
In that case, James, do you want to answer the last question, and then I guess we can call it a day.
I'll give it a go. So this really comes full circle back to what Gavin Strange was talking about at the beginning of the first session. In that I think it's true, engineers do live busy and intense lives, but actually I think there is a real value in making time for kind of doing things that recharge us and energize us. And for me personally, and I can only talk to my personal experience, a lot of that is around creativity. And I often think that people think making time for creative stuff is what's the word, kind of self-indulgent. but actually the world needs creative engineers. I mean, I hope above all else that is what came across over the last 2 hours is we can't just carry on doing things as we are. We need creative engineers, but actually creativity can also be a really refueling thing, you know, spending time, whether it's drawing or reading or writing or just being outside and having space for your thoughts and, you know, to think, or whether it's eating great food or talking to friends, or all of these things that fuel creativity, I think are really valuable investments, and they're really good for looking after you and your well-being. So I try really hard to have those things in balance on a daily basis for myself, and I would really encourage everybody else to do the same. And that's what I got.
And just for everyone on the recording, the question was a more general question for everyone. Engineers can lead very busy and intense days. Do you have any advice on avoiding burnout? Yeah, what I'd probably add to it, although, you know, still a student, is that I often find myself busy but not productive. And sometimes I think like I'm just trying to do lots but not really accomplishing anything, and often it's because I'm just doing too much on one plate. So I'll just take a step back, go and do something else, you know, whatever I like to do in my spare time, often creative stuff as well, and then come back to it. When I do, I find that I get more done without being as busy and without days being as intense. And a lot of that comes down to like timetabling when I work.
Yeah, and following on from that, I very rarely work weekends. I always take at least one day off a week, but virtually all of my working life, I've taken 2 days off a week, and I do try and really boundary my time, and I would really encourage others to do the same. And it takes discipline and it's hard work, but actually the payoff is really big, and that when you do work, you are more focused, more able to achieve things, and less distracted if you're rested. But it's tough. It's tough to get there, and it feels, you know, it's like many things in life. At the beginning, it feels really hard, but it does overall long-term payoff.
Brilliant. Well, I think we'll have to call that the end of the session then.
Thank you, Gabriel.